In this video, we're going to talk about how to solve rational equations. So these are the steps we're going to use, and I will model these in the examples in a moment. But the first thing that we're going to do each time is we're going to look at all the denominators, and we are going to find the least common multiple of the denominators. So if we have a denominator that needs to be factored, we would want to do that first. And we will abbreviate least common multiple as LCM. So once we find that least common multiple, we're going to multiply every single term by it. So it doesn't matter if it's a fraction or not, it gets multiplied by that LCM. After that, we'll be able to simplify the LCM and any of the denominators. What we're going to do, though, is ignore the numerators. So we're going to leave the numerators alone for now. And then after this step, you should have no fractions left in your equation. If you still have some fractions left, then something went wrong earlier on. So once all of our fractions are cleared out, we can just go ahead and solve the equation. Now, we need to make sure to check for extraneous solutions. So remember, those are the solutions that look perfectly fine, like let's say x equals 4, but when we go to plug it in, it makes the denominator 0, which means it can't actually be a solution. So we would say that x equals 4 then is extraneous. So it looks like a good solution, but it's not. Okay, so our first example, we only have two denominators here. We have a denominator of 3 and we have a denominator of x. So our least common multiple would need to include the 3 and the x. So just like if we were going to get a common denominator, but we're not going to get a common denominator, but if we were, it would be this 3x. So what we're going to do is we're going to take each term and we're going to multiply it by 3x. So we're going to multiply the 1/3 by 3x. We're going to multiply the 10 over x by 3x. And we're even going to multiply this -3 by 3x because every single term needs to be multiplied. So if you found the correct least common multiple, LCM, something in this 3x should cancel out with your denominator. So in this case, these 3's will cancel out. So then what we're left with is this x that's being multiplied by 1. And I'll go back and simplify that in a moment. In my next term, so I have this subtraction sign here, this x in the numerator will cancel with this x in the denominator. So I'm left with that 3 there that's being multiplied by 10. And again, I'll simplify that in a moment. And then over on the right-hand side, I don't have a denominator, so nothing can cancel. So I just have the -3 times 3x. Okay, so now let's start simplifying this. 1 times x is x. -3 times 10 is -30. And then over here, -3 times 3x is -9x. So I'm going to start by moving the x over. I'm going to subtract it from both sides. So -30 is equal to -10x. And then I'm going to go ahead and divide both sides by that -10 so I can isolate x, which means x is equal to 3. Now I really quickly want to check and make sure that it won't make my denominator 0. So if I replace this denominator with 3, I'll have a denominator of 3, which is fine, as long as it's not 0. So my solution here is x equals 3. Okay, so in this next example, we want to find the LCM again, the least common multiple. So if I were to make the denominators the same, so my numbers are already the same. They're already both 2. So that's part of my LCM. And then I only have one variable here, which is x, so that is also part of my LCM. So if I were to make all of these the same to get a common denominator, I could easily make them all 2x, and then they would all be the same. But remember, we're not making them the same. We're getting them to cancel out. So each term now will get multiplied by 2x. So 2x gets multiplied by 2 over x. 2x gets multiplied by 1/2. And I'm also going to multiply this 7 over 2x by 2x. So again, your denominators should cancel out now. So looking at the first term, this x and this x will cancel. So I'm just left with these numerators, so 2 times 2. In the next set of terms, these 2's will cancel. So I have this addition sign here, and then I'm just left with x times 1. We'll go back and simplify all that again. And then in this last term, both the 2x and the 2x cancel top and bottom, so we're just left with that 7. That's all that's remaining there. So now I'm going to start simplifying. 2 times 2 is 4. X times 1 is x, and that is equal to 7. So all I have to do is move the 4 over by subtracting it, so x is equal to 3. Again, look at your denominators. It'll make this one 3, and it'll make this one 6, which is fine as long as it's not 0, so our solution is x is equal to 3. Okay, so in this next one we have a bunch of different denominators, but again, we're just going to start by finding the LCM, and we are going to look at the numbers. So 2, 4, and 2. So if I wanted to make all of those the same, I would make them all 4, because 2 is a multiple of 4. If I look at my variables, they're all the same. They're all just x to the first power, so that also has to be part of my LCM for x. So every term will get multiplied by 4x. So this 2 over x gets multiplied, this 1/2 gets multiplied, this 9 over 4x gets multiplied, and this 1 over 2x gets multiplied as well. So something should cancel or reduce here. So if I look at this first one, I can see that the x's cancel. So we are left with 4 times 2. Now in this next one, nothing just directly cancels, but I can divide this 4 by 2, which will leave me with 2. So what I'm left with is 2 times x times 1. Over here, the 4 x's will just cancel, leaving us with 9. I have this subtraction sign. So the x's will cancel again here, but the 4 and the 2 don't cancel, but I can divide 4 by 2, which is 2, so all I have left is 2 times 1. Now I can start simplifying. 8 plus 2x is equal to 9 minus 2. So 8 plus 2x is equal to 7. I'm going to move the 8 over, so 2x is equal to -1. And then when we divide by 2, we get x is equal to -1/2. So if I plug it in here, my denominator is -1/2. If I plug it in here, that would give me -2. 4 times -1/2 is -2. And if I plug it in here, I would have -1. So 2 times -1/2 is -1. None of those are 0, which means this is a perfectly good solution. In this next example, we have binomial denominators. So we talked about this a little bit before, but remember, we have to think about this as having parentheses around it. So I have to keep the y and the +2 together. I can't separate those out. So the nice thing about this one, though, is that the denominators are already the same, and we only have the 2, so our least common multiple is just y plus 2, this binomial. So every single term will get multiplied by y plus 2. So I'll multiply that by y minus 3 over y plus 2. I also have to multiply the 3 by y plus 2. And then I'm going to multiply the 1 minus 2y over y plus 2 also gets multiplied by y plus 2. So every single thing gets multiplied. So here, these y plus 2's top and bottom will cancel, leaving me with that y minus 3. Here, nothing cancels, so I'm just going to leave it for now as 3 times y plus 2. I still have the subtraction sign. And then these y plus 2's will cancel. Now, I'm going to leave that numerator, because it's a binomial, I'm going to leave it in parentheses because I'm going to have to go back and distribute the subtraction sign. If you don't do that, your answer will be wrong. So y minus 3 is equal to 3y plus 6 when I distribute. Now I'm going to distribute that negative, so negative times 1 is negative 1. Negative times negative 2y is positive 2y. Let's simplify. So y minus 3, I can combine the y's, so 3y and 2y gives me 5y, and then 6 minus 1 gives me positive 5. So let's move this y over. So negative 3 is equal to 4y plus 5. And then I'm going to move the 5 over. So negative 8 is equal to 4y. And then finally, I'm going to divide both sides by 4. And we get y is equal to negative 2. Now this time, when I go to check it, if I plug it in here, I would have negative 2 plus 2, which is 0. I can't have 0 in my denominator. So y equals 2 is an extraneous solution. It looks like a solution, but it actually isn't. Okay, same idea in our last example, except we have one more denominator. So remember, I have to think about these x minus 1's as if they have parentheses around them. So if I look at the denominators and I'm finding the least common multiple, I know I have to have this 3, it's all by itself, and I have to have that x minus 1. Now, I'm not going to distribute. I'm just going to leave it like this. It's going to make everything much easier to cancel out. So I'm going to multiply everything by 3 times x minus 1. So I'll have 3 times x minus 1 being multiplied by this 2 over x minus 1. Then I'll have 3 times x minus 1 being multiplied by this 5/3. Then over here, I'll have 3 times x minus 1 being multiplied by this 4 over x minus 1. So now I'll see what I can cancel out. So here the x minus 1's will cancel, and I'm left with 3 times 2. In this next one, the 3's will cancel. So I'm left with this x minus 1 times this 5. So I'll go back and take care of that in a minute again. And then over here, these x minus 1's will cancel, so we're left with 3 times 4. So now we're going to do any distributing or multiplying. 3 times 2 is 6. I need to distribute this 5, so it kind of looks backwards. So 5 times x is 5x. 5 times negative 1 is negative 5. And then over here, 3 times 4 is 12. I'm going to simplify. 5x plus 1 is equal to 12. Then I'm going to move that 1 over. So 5x is equal to 11. Divide both sides by 5, and x is 11/5. So again, if we go to check that, the only thing that would make this denominator here 0, or this one, would be x equals 1. So 1 minus 1 is 0. This is not x equals 1, so this is not extraneous. This is our answer.